As someone new to web development or Niantic Studio in general, it can be quite a hassle to get started making actual interactions. In this video, I'm going to show you how I made a very simple drag and drop system, and this also will be an introduction to state machines, because making this system also introduced me to how state machines work in JavaScript. I already got used to them in C#, but the way this works is very different with a lot of different syntax. So I hope this video also teaches you how to work with them properly. So right here we got a beautiful cube, and we got the empty project of Niantic Studio. The only thing we changed is we got the world type right here. By default this is 3D only, and mobile is AR. So this way we can get a preview of how it would look on a phone, so we can test it a bit better. So for the rest in the scene, we got a box, an ambient light, and a directional light. To the box we added a physics collider, which is now dynamic instead of static. This way it falls down. But it does need to fall onto something, and for this we're going to use another box, make it very big, 100, move it down minus 51. For some reason 50 does not work. That's very interesting. And it can receive shadows. On the box we did check cast shadows, and to fix some rendering issues we set it to both to double, since the single one doesn't really work for some reason. We're going to add a static physics collider on the very big cube. And right now if we build this, the box should just fall towards the cube and stay there. This looks right to me. Let's just rename these. Ground. And the box can stay box. Next we're going to make a new script. You can do this by adding the plus right here, new file and new component file. And let's call this draggable. Now I have the code in another project, which you can actually visit in the description below. But for this project we are going to go live through it, so it's not going to be a copy-paste. Good luck with it. The project is right here. You can simply drag and drop some ducks. It's amazing, you should try it out. And here's the project we got this to set up. Again, this code will be linked in the description below. This is a bit more work in progress since I'm trying to add the interaction of them following your finger. But since this is just an introduction, we are going to make sure it just stays in the middle and follows the camera. So, since it can follow the camera, that's probably the easiest way to start. We need to make a reference to the camera in the scene. For this, we're going to add a camera, and this will be ECS.EID. Every object has their own EID, and that's basically how they are identified. Might even be identifiable ID, not too sure on that. And that's just basically making a reference in the inspector right here. So we can see it right here. These references are in the schema right here. So we want to have a reference to the camera. We want to have a distance to the camera. This will be a float, so a floating point number. And we want to have a movement speed, which also probably is a float. Now for the defaults, you can't default the camera since it has to be assigned, but we can put distance to camera, which could be 1. It's probably quite right. I would recommend to try out multiple versions and see what feels best, since it can be a bit different on how it feels versus how it would actually behave in the real world. So definitely try out both. And for the movement speed, I defaulted this to 50. Now for the data, we actually, just to make it accurate, we're going to store the original mass of the object. So original mass, and this will be a floating point as well. The mass is basically the mass right here. And the thing is, if you put this to 0, it is static. And as you can see, it just goes back to static. I find it a bit confusing that you can't change this dynamically somewhere, because now if you put it back again, it's suddenly 1, which is to me a bit confusing. But just know if we're going to do this in code, if we put it to 0, we're putting it to static. And we want to memorize what the mass is originally, because if someone has a very heavy object and they drag and drop it, you don't want to change the mass to an arbitrary number. So we want to store that internally. So the data structure should be quite simple. And if we add our draggable script here, You can see we got the reference right here, and here we can select our camera, and these are pre-filled because we put them in the defaults right here. Now there are three more functions here, and we're going to add a third one after a bit. We got add. This is called when the component is added or when the application starts. We got tick. This calls a set amount of times per second. So if you want to do something like a smooth animation, you could do that in tick. And you got remove. This is called when the component is removed. I think that should be quite self-explanatory. We're not going to use that many of these. We're not going to use the tick nor the remove, so we're going to remove those. But the add is fairly important. First of all, we want to make a reference to the original mass. And that should be done fairly simply. So we want to have the collider, which is a constant. Oh, sorry, it's a constant collider. And that's gotten via ECS. I think it's physics. No, it's collider.get. So we're getting a collider. Then we need to input which world we're at. That's just passed in with the variables out here. There are some variables you can pass along, like the world, the component, and also the data. Oh, good lord. Data attributes. No, attributes. You can also get the data via component.data, but it doesn't work in child functions. So for now, I'm going to show you how to do this in a way that works across the board, although it might be a bit easier if you just do components.data.originalMass. This is just a failsafe, so we'll show you later. The world and the EID. And we have to do components.eid since we're reading there. And I see I made a very big typo here. It's a collider. And there we go, that should work. We got an error right here. Alright, we'll just go on and see what happens. And now we want to check if there's actually a collider on here. I really can't type today. So if there is a collider, we want to store the mass. And for this we need the data attributes, and we're going to just make a const. Data is data attributes that cursor, and then the EID again. That's the component.eid. And now we can just simply use data original mass, and you can use any other object in the data field right here, equals the collider dot mass. Let's see why this is being angry with me. Add which is declared. Doesn't it have a data attributes class? Why not? Do we need to do component of data attributes? Ah, I think that's better. Yeah, this is how it works. Sorry, I had to double check the original script. So this way, whenever the application starts, it just stores the original mass, so we can use that later on when making stuff interactive. Relatively easy so far. Now we're going to get into the hard thing, which is state machines. For this, we're going to make, well, a new state machine. And the syntax is some getting used to, but after a while you do get used to it. And this takes in the world, the EID, schema attributes, and the data attribute. Which will be passed into the method, which is shown like this. Alright, it is not happy with me at the moment. Let me quickly see why not. Ah, there we go. We have to use curly brackets here, since it's a collection. Alright, so it's normal brackets, curly brackets, and here's all the data we need. and then you close it off again, and then you declare the method which is going to run. And it's now winding about me. It goes right here, I think. No, it should be there. Does auto fix itself? Of course it doesn't. Still waiting for something. There we go. You didn't think there. Alright, so here to make a state, we're going to use ecs.defineState, and we're going to give it a name, and we're going to start out in the idle state. That should speak for itself. Then for everything which is new to this, I recommend putting it on a new line. So if something is the starting state, we're going to call initial. What this does, it makes sure this is the first state it goes to, which is fairly nice. And next we want to have something to happen when it's on enter. So you can have on enter, which is whenever it enters state, on exit when it exits the state, and on tick, which happens a set amount of times per second. For us, we're going to use most of the things in on enter for this, so that's really nice since it's fairly simple. And the syntax right here should be, if I'm correct, this? Yeah, there we go. And this is basically the way you can have any kind of variables in here, and this is how you declare a method. It's a bit confusing, but you get used to it. So now first we want to get the collider. So const collider is ecs.collider. Don't we need to use get? I think this also works. Oh no, we don't get mass. This is just a reference to the collider, it seems. Yeah, never mind. We're going to use the collider right here. And we're also going to get the collider like this. And we already got the EID right here. There we go. We got a collider. And now if we have the collider, which is always good to check to make sure you don't run into any errors, we want to get the data right here, basically this code, which it is not happy with since we already got the data attributes right here. And we got the EID right here. And we're not going to store the original mesh, but we're going to put the collider mesh. Wait, dot mass. There we go. Equals to 0. And what this does is make... Why doesn't this work? It is read-only. Then we need to do this slightly different. We need to get the collider.set world EID, and then for the data, you need to have this, since it's a read data collection in a way, we need to set it like this, so the mass will be 0. There we go. So right now, if it enters, it should be static. And to debug this, we are going to, if we can go to here, have the live sync on, which might be a bit easier to check everything. We're going to save this, it should all compile, and our box should be up and running. You can of course also console log this, but I like to see it in the editor itself. So our box should be static. There we go, it's static. That's about right, since it initially enters the state and makes it static. Now that's just to check if it did work, but of course in the idle state it shouldn't be static but dynamic. But this was just to check if it is functioning, so that should be the original mass of course. Since, well, once it's idling it should just drop to the ground and do nothing. Sorry if it might be a bit confusing, but this was the best way to show it without writing the whole script for the dragging state. And now we want to transfer to a different state, which is done using the onEvent. For me it was some getting used to, because onEvent sounded like, to me, the same like listen, because listen just listens to an event and then calls a method, but onEvent listens to an event, but instead of calling a method, it goes to a different state. So that's something you should really keep in mind. So the event of this should be ecs.input screen touch start. So as soon as someone touches the object, this is not the full touch screen, this is just on the object itself. Again, that is some getting used to. And we want to have the next state be dragging. And we don't need any arguments. So right here we got everything set up that as soon as something is idle, it has physics, since it has a mass, which isn't 0. And once someone touches the screen, it goes to the dragging state. So now let's make that dragging state. ECS.define state dragging. This is not going to be initial. We are going to have an onEnter. And this is going to do something very similar to here. So let's copy over this code. And instead of setting it to the original mass, we're going to set it to 0, so it's static. And it's going to actually follow our cursor, because otherwise it will just fall down to the ground with physics, teleport back up, and it would look really bad otherwise. And it also makes sure we don't need any data attributes right here. We just need to set the actual collider. That's great. That's fairly simple, right? Next, we are going to add an onTick here. This is because every frame, basically, every rendered frame, we want to make sure that the object moves to the center of the screen. So for this, I am going to copy and paste this code over. That's because it's a lot of code, and it's written by ChatGPT. As much as I don't like to admit it, it is a lot easier to get this code up and running with ChatGPT, but I will guide you through every step of the way. So first we get the schema attributes. This is done the same as with the data attributes, just instead of getting the data, we're getting the schema right here, these values. That's very nice. Then now from the schema we are going to get the camera, the distance to camera, and the movement speed. Actually see the movement speed isn't currently used. It's got follow speed here. Let's quickly update that. Nice. We're going to get the position and the rotation of the camera. This can be ignored. This was a work in progress for getting the finger position. We're going to get the forward of the camera. That way we know where the camera is looking towards using the rotation and the position. We're going to get the forward offset, which is an offset from the camera going forward. And we're calculating the new position of the object right here, which is the camera combined with the forward offset. This is just basically right into the way the camera is looking. And we want to smooth out the movement so it's not instantly, since it doesn't feel that good in AR or any interaction. So we want to smooth the transition right here, and this does the code right here. All this code is very math heavy, but as long as you understand what it does without necessarily understanding why it does all these calculations, it should be good enough to get working with this. And then lastly, something which you can also do this via ECS. It depends on the sample you use, how they do it. But first we're going to set the position using world. So we have the world right here. We're setting the position to the current EID, which is the box. And we're basically setting each position right here. So you need to do everything separately. It's not like Unity where you have 1 vector 3. You need to do it per axis. And that's actually about it. We want to do one last thing, which is of course we want to drop the object when we release our screen. So for this we have an onEvent again. So this is to transfer to a different state. The event will be ECS input dot touch end. And we will transfer to idle. And that's about it. This is the whole script to make something draggable. I want to give a quick heads up. If you want to make this follow the cursor, you can do this with listen to the, well, EIE is the target. And then we're listening to ECS.input.move. So we actually see how the finger moves. And here you can have a method like follow finger. And up here you can have a method called follow finger. We can make this a const, I guess. Still getting used to the syntax, so don't worry there. And we're actually going to have a variable here, event data. It's always some getting used to have all these brackets everywhere. Is this how this works? No, it isn't. That's fun. There we go. And you get event data dot position. And this is basically the relative position, so between 0 and 1 of the touch position. Again, we're not going to get into this much more right now, since it is a lot more complex and there aren't any good helper functions to get the world space data. So for now, this is about it. And once we're getting in our experience, let's quickly put the ground to shadow only to make it a lot more immersive. Play. We should see the cube, and once we touch it, it goes very close, and it drops again. We can, of course, change the values right here. Since it's live debugging, we should be able to do this dynamically. And let's put this to 10. Oh, we still have to save it since the box is now gone. Can we still see it somewhere? I don't think we can. Alright, let's save it and restart the app. Would be very nice if we have some 3D locations here as well to just test our apps with WASD. So if someone from Niantic watches this, that would be great. So right now, it goes slower, it falls to the ground again like normal, and you can pick it up again. And we can see it floating around in the scene right here. So this is a very quick interaction, and an interaction which is, to me, very important to AR. And that's why I want to make this available. So in the description below, you can find this project, which is basically this code polished up with some ducks. And here you can experiment, clone it, do whatever you want with it. So I hope this was helpful. If it was, definitely let me know. And if you have any questions, always feel free to reach out and ask me. That is completely okay. And I will try to help out as much as possible. And otherwise, the Niantic forums or the 8-ball forums are also a good way to get some support. If you want to see anything else from Niantic Studio, definitely let me know as well. And I hope I will see you in that video. Take care. Cheers.